Here's an integral that there is no obvious way to accomplish it. It is a rational function. It is a proper fraction. There's no, you could try letting u be the bottom, but that's obviously not going to work. So we're going to use the fact that we know the integral of a squared plus u squared being an arctan to do this. And how we're going to do that is we're going to use the method of completing the square. So we're going to complete the square on the bottom. So I'm going to show you how you do that. It's probably be done before if you like sometimes you can solve a quadratic equation using completing the square method, if you remember that. Um, all that is getting a quadratic into a perfect square trinomial so it factors into a nice little binomial squared. And you accomplish that by adding b over 2 squared. So we're going to do that with the bottom in detail here before we try to integrate this. So the bottom is a quadratic. And to complete the square on a quadratic, you have to add b over 2 squared. So ignore the c, add b over 2 squared here, and it will be a perfect square trinomial, can't speak. However, that only works, see that a, is if a is 1. So looking at what we have here, we have a quadratic and a does not equal 1. So we're going to have to factor so that it does equal 1. And this is an obvious factor of 2. So we have this quadratic left over. X squared plus 4x plus 10. So now we're going to complete the square of just this part inside the parentheses by adding b over 2 squared right here. So first of all, let's figure out what b over 2 squared is. B is 4 in our quadratic, so b over 2 squared is 4 over 2 squared, which is 2 squared, which is 4. So I'm going to add that right here. But of course, that changes the whole thing. So to take care of that, you also have to subtract it. So in essence, you're adding 0. And then don't forget, we still have that plus 10. So the first 3 terms now will be a perfect square trinomial. If you factor it, depending on how you factor, you could think of it as x plus 2, or you could recognize it's a perfect square trinomial. And you know that factors into x plus 2 quantity squared. And then you have what's left over, which is negative 4 plus 10, which is plus 6. So the last thing I'm going to do now is multiply this 2 back through. So I have 2 times x plus 2 squared plus 12. All right, so now I have a new problem. Well, I don't have a new problem. I have a problem that I can integrate a little bit easier. So I'm going to get rid of all this because I'm done with it. Where is my, hold on a second. All right, I'm going to get rid of all this. I'm going to remember what I had here. And now I'm going to start the problem. So this turns out to be the integral of 6 over 2 times x plus 2 squared plus 12. Now this is looks like an arctan. This is u squared. This is a squared. So u squared here, if 2 times x plus 2 quantity squared is u squared, then u would be the root of 2 times x plus 2, because that's the only way to get this squared to be this. Now, if you don't like thinking of it that way, just think of u squared is this part of your integral, the first term, and then just square root both sides. So u would be the square root of 2 times x plus 2 squared, which would be the square root of 2 times x plus 2. And a is root of 12. Now du would be the root of 2 times dx. So when we integrate this, we're going to have a factor of 1 over root 2. So there's a lot going on here, but if you're good with the old arctans, the ones you would have done previous to this, I think it's pretty straightforward. So this is a pretty good, pretty perfect arctan, except we have this. I should have put du here. So we do have a factor of 1 over root 2 out in front because of the dx, but we also have this 6 as a constant. So the integral would be the arctan, but with a 6 over root 2 constant. The formula for the arctan is 1 over a times the arctan of u over a plus c. So that's it. You could simplify it a little bit. You can multiply root 2 and the root 12, and you can combine these roots to make it 1 over the square root of 1 over 6 or 1 over root 6. And that's about it. You could simplify the root of 24 because that's 4 times 6. So it would be 3. If that's 2 root 6, this would be 3 over root 6 arctan. That's just simplifying square roots. So that's how you do it. Let's just do a quick check of our answer. It looks a little bit different, like it always does, just depending on how you're going to simplify these square roots. Instead of root 6 over, or 3 over root 6, they simplified it to be 3 root 6 over 6. Again, I just want to make sure we have that 3 root 6 over 6, which would be root 6 over 2, which is equivalent to root 3 over 2, because root 3 over 2 is, if you rationalize this, that would be root 6 over 2. So yeah, either of these answers are okay. Also, Wolfram's is okay, but that's it. So I'm going to come out with a couple other videos that aren't going to focus so much on the completing the square, but they are going to involve completing the square. So stay tuned for those.